video presents the central limit theorem in practice, and it's probably worth 6 test points somewhere along the way. So first situation, questions, we would have 2 questions or about 6 points. First question could be, which graph would best represent a single simple random sample of 500 values from the given population? And the second question could be, which graph would best represent a distribution of 500 sample means from simple random samples, each of size 50? So our n in this case is 50, not 500. 500 is how many times you drew out. N for number 1 would be 500, but it's a single, just one simple random sample, and you expect it to be the shape of the original population with fewer bars as far as height, fewer number, and the mean would be about the same, and the range and standard deviation would be about the same. Number 2, which graph would best represent a distribution of 500 sample means from simple random samples, each of size 50? So n is 50. 50 is greater than or equal to 30, so the central limit theorem applies. We end up, whatever shape we start with, we end up with a normal distribution with a mean that's approximately the same as the population mean, and a standard deviation that will be the standard deviation of the population divided by the square root of n, which is 50 in this case. Here's the population for the first 1 and 2. It looks approximately skewed to the left, so we're looking for a graph among our answers that looks skewed to the left, where mu is approximately 30.3, and sigma for number 1 is 7.1 or so. In other words, this range. So you got that in your mind? 30.3 and 7.1 divided by the square root of 50 for number 1. Oh, it's not A. A looks approximately normal, so it's a possible answer for B, number 2. B, that's very possible. The mean's a little off, which is going to happen. The standard deviation is right on. It's the right shape. It's skewed to the left. And C is out for number 1. So the correct answer for number 1 was B. Now, to find the correct answer for number 2, it's either A or C, but we have to take our original standard deviation of 7.1 and divide by the square root of 50, and we get 1.00. So A looks like it's probably it. Let's double check. Yeah, 2.23 is too large a standard deviation. 1 and 0.99 are close enough to say, yeah, this is the right answer. So the correct answers for number 1 was B, number 2 was A. On down we go. 3 and 4. Which graph would best represent a distribution of 1,000 sample means from simple random samples, each of size 100? Okay, we're talking about sample means. This is going to be the one that becomes normal, and the standard deviation gets smaller. N is 100, so we can just divide by 10 this time. That'll be nice. The second one, we have a single simple random sample of 1,000 values. That one's going to look like the original population, approximately the same mean, approximately the same range and standard deviation. Okay, here we go. Here's our population. What shape is that? Skewed to the right. Mean is 16. Standard deviation is 10.2. So let's go back and double check this. Number 3 is going to be our normal curve. Number 4 is going to look like our original population. Okay. So, I would say, even though it doesn't look very good, A is probably going to be the correct answer for number 4. And what was our standard deviation? So we're looking for a standard error of about 1.02 and a mean of about 16. That one, the mean's way off. Standard deviation looks, okay. That one looks much better. So the correct answer for number 3, the one about the sample means, was C, and the correct answer for number 4, the one about simple random sample, was A. Okay, 2 more. Which graph would best represent a single simple random sample of 10,000 values? That is not going to be some central limit theorem. That is going to look like the original population. 6, sample means, there it is, 10,000 sample means. They took a whole bunch of simple random samples, a whole bunch, each of size 50, found their means, graphed them all. And so we're going to divide our standard deviation by the square root of 50 again. It's going to be approximately normal. Okay, so here we go. That is very skewed to the right. Population mean is 16.5. Standard deviation is 12.1. We're going to divide our standard deviation of 12.1 by the square root of 50, and we're looking for a standard error of about 1.7. So let's see, 16.5, 1.7. And number 5, we're looking for not central limit. Number 6, central limit. Okay. There's the not central limit. So that's number 5. C is 5. Now we have to choose between these two. Means are the same. Standard deviation. The standard deviation we decided we needed was 1.7. So that means number 6, the correct answer for number 6 is B.